Hi children, how are you? I hope all are fine. That's very good. Then today we are going to discuss about chemical bonding. So in this topic, so are you seeing the magnet? Yes. So all are see the magnet. So that magnet come closer, what will happen? So the magnet is attractive. So in the magnet is one end is negative charge and then another one is positive charge. So the magnet is attractive. So in the magnet come closer, they attract in each other and held together. Yes. So this magnet forced together due to the force, that is the magnetic force is like that. So the atoms or various element comes to close each other, that combine with each other to the form of molecule. Okay, so what is molecule? A chemical bond. Okay, a chemical bond may be defined as the force of attraction. So in the red mark, so in the what is molecule? A chemical bond may be defined as the force of attraction between the atom that bind them together as a unit is called molecules. Okay, this is the molecule definition. So all of you study. Okay, so next one is the Coastal-Lewis approaches to chemical bond. So this chemical bond is otherwise name is octet rule. Okay, octet rule. So oct means 8. Okay, oct means 8. So that 8 means in the electrons in around the valence shell, in the presence of 8 electron is called 8 rules. So atoms of various element combine together in different waves to form chemical compound. Okay, to form chemical compound. So in this formation is depends upon the Coastal-Lewis theory. Okay, Coastal-Lewis theory. So it is based on the Coastal-Lewis theory is based on the concept of electronic configuration. So what is electronic configuration? Yes, the distribution of electron in different shells. Okay, the distribution of electron in different shell. So in the first cell and second cell and third cell. So in the first cell is present of electron in 2 electron, and then second cell the presence of electron in 8 electron. So in the distribution of electron in the different cell is called the electronic configuration. Yes, so the noble gases of electron, okay, noble gases of electron is completely filled in the valence shell. Okay, completely filled in the shell. So the noble gases element in the valence electron, the valence shell electron is 0. So in the noble gases is completely filled the electrons. The noble gases is completely filled the electrons. So all of you study the 11th unit in the atomic structure unit. So in the periodic table, so all of you take your science book, page number 142. So in the periodic table, so in the last 18th group, okay, in the last 18th group and 8A, okay. So in the 18th group is called inert gases or noble gases group. So in the presence of element is helium, neon, argon, krypton, xenon. Okay, so the helium, the atomic number is 2. Okay, neon, the atomic number is 10. Argon, the atomic number is 18. Then krypton atomic number is 36. Xenon atomic number is 54. Radon atomic number is 86. So these all elements, it's completely filled the shell, completely filled the valence shell. So in the valence electron, the valence number of electron is 0. So this is the noble gases elements. This is the noble gases elements. So in this noble gases elements, so the have little or no tendency to combine with each other or with atoms of their elements. So in the stable electronic configuration, so in the stable electronic configuration, so in the electronic configuration means is 1s2, 2s2, The electronic configuration means the electrons is arranged in the system. So the electrons is arranged in 1s2 and 2s2 and 2p6 and 3s2 and 3p6, then 4s2. So in this order the electrons will be arranged. So in the first layer only 2 electrons are present. In the first layer only 2 electrons are present. Then the second layer 8 electrons are present. So 2s2 and 2p6. So totally 8 electrons. So 8 electrons are present. Then third layer 3s2 and 3p6, that the 8 electrons are present. So in the helium, neon, argon, krypton, xenon, radon, so the atomic number and then cell of electronic configuration. So in the helium 2 electron, so the first layer of the shell is filled in 2 electron. Then neon number 10, so the total number of shell is 2 cells. Then the cell electronic configuration is 2 and 8. Okay, 2 and 8, because 1 has 2 first cell and second cell is 2s2 and 2p6. Okay, this is the second cell. Then the argon is 2, 8 and 8. So in the last, you see the last number, okay, last all elements number 8, 8, 8, 8, 8. So this is the oct. So the oct means 8. So this is the oct rule of Coastal-Lewis approaches. So in the Coastal-Lewis approaches, it depends on the electronic configuration. Okay, it depends on the electronic configuration. So in the except helium, so the helium is only 2 electron. Yes, no, not in the 8 electron. So it not present in the 8 electron. So only 2 electron. So in the helium, is all other noble gases have 8 electrons in the valence shell. Okay, so helium is the valence shell is 0, so it is completely filled. So it has no more electron can be added. So in the valence cell, the valence cell is stable. Okay, in the valence cell is stable electronic configuration. So in the noble gas atom, okay, in the noble gases atom is helium, neon, argon, krypton, xenon, radon, is the no gain of electron and no losses of electron. Okay, no gain of electron and the no losses of electron, and there the valency is 0. Okay, and there the valency is 0. So this is the monoatomic gaseous atom. This is the monoatomic gaseous atom. So it is based on the Coastal-Lewis theory. It is based on the electronic configuration. So next one, in the chemical combination between the atom. The chemical combination between the atom. So in this theory is electronic theory of valence in the octet rule. Okay, in the octet rule. So the molecule combine, okay, molecule combine together in the atoms. Okay, molecules combine together in the atom. In the inert gases is completely valence shell. Okay, inert gases not combined to the other element. Inert gases element not combined to the other element. So it is the complete valence shell. So incomplete valence shell means the other atom. Okay, the other atom is hydrogen and lithium, beryllium and boron. Next one is the sodium chloride. So these are the incomplete the valence shell. So one electron or 2 electron is gain or loss. 1 electron is gain or loss, then become the noble gases electronic configuration. So this is the stable electronic configuration. So the transfer of valence shell from one atom to another, or by sharing of valence electron. Sharing of valence electron. So the stable outer shell of 8 electron. Okay, the stable outer shell of so the outer shell presence of 8 electron, it is the stable. So outer shell is not present in the 8 electron, the shell is unstable. Okay, so this is the concept of Coastal-Lewis approaches in the chemical bond. So what is 8 rule or what is octet rule? So the tendency of atoms to have 8 electrons in the valence shell is known as the octet rule or 8 rule. So one example, sodium and chloride. So sodium chloride. So all of you studied in the 11th unit atomic structure unit and their electronic configuration. So what is the electronic configuration of sodium? Yes, the electronic configuration of sodium is 1s2, 2s2, 2p6 and 3s1. Okay, so the first layer is 1s2, the presence of 2 electron completely filled. Then the second layer is 2s2 and 2p6, 8 electrons is present completely filled, and third layer is 3s1. Okay, 3s1. So in this third layer is unstable. In this third layer is unstable, it not completed. Yes, so in the sodium is losses of 1 electron. Okay, the sodium is losses of 1 electron. So the sodium atomic number 11 is losses of 1 electron. Then get sodium, the atomic number is 10. So the 10, so you see the table 13.1, the 10 atomic number is neon. Yes, so near the noble gases. So the sodium is losses of 1 electron is near the noble gases group element is neon. So the outermost valence shell is 8 electron is completely filled and the stable valence shell. Okay, this is the sodium valence electron. Then another one is the chlorine. So chlorine electronic configuration is 1s2, 1s2, 2s2, 2p6 and 3s2 and 3p5. Okay, so the electronic configuration is 287. Okay, 287. So the chlorine is gain of 1 electron. The chlorine is gain of 1 electron. So the chlorine gain of 1 electron means the chlorine electron is the nearer to the noble gases is argon 18. Okay, argon 18. So chlorine atomic number 17. Chlorine atomic number 17. The electronic configuration is 287. So in the last one 7. So valence electron is 1. So the gain of 1 electron, the last cell is completed in 8 electron. Okay, so the chlorine is stable electronic configuration of argon. So in the table 13.2, okay, the table 13.2, the element and atomic number and electron distribution and the valence electron. So boron atomic number 5, the electron distribution is 2 and 3. So 5 electrons, first cell 1s2, 2 electron filled, and then second cell 3 electron filled. Then the valence electron is 3. Then nitrogen atomic number is 7. Then the electron distribution is 2 and 5. Then valence electron is 5. Then oxygen atomic number 8. The electron distribution 2 and 8. And valence electron is 6 valence electrons. Then so the 3, 5, 6 and 1. So this is the outermost presence of outermost electron. In the outermost layer, the presence of electron is valence shell electrons. Okay, so in the next one, Lewis structure. So the Lewis structure is nothing. So in the valence electron, okay, in the valence electron is denoted in the dot. Okay, the valence electron is denoted in the dot. So for example, in the hydrogen, so hydrogen atomic number 1 and then valence electron 1. So is Lewis dot structure is hydrogen is denoted in 1 dot. Then lithium the valence electron is 2. So so the Lewis dot structure is helium He, the dot is denoted in 2. Okay, so the beryllium atomic number 4, the valence electron is 2. So the electronic configuration 2 2. So the first layer is filled in 2, then the second layer is incomplete in 2. So the valence electron is 2. So the beryllium 2 dot means 2 valence electron. Okay, 2 dot means 2 valence electron. So in the next one, carbon. So carbon atomic number 6, the electronic distribution is 2 4. So the valence electron is 4. So the Lewis dot structure is carbon 4 dot. So the 4 dot means 4 valence electron. So in the electron distribution or electronic configuration, in the last number 1 2 beryllium 2, carbon 4, nitrogen 5, oxygen 6. So in the 2 4 5 6, so this number is valence electron. So in the valence electron number is denoted in the dot form. Okay, valence electron number is denoted in dot structure. So this is the Lewis dot structure. Okay, this is the Lewis dot structure. Then the next one, the types of chemical bond. Okay, types of chemical bond. So in the chemical bond there are two types. One is strong bond and another one is weak bond. So in the strong bond further classified into four types. One is ionic bond, covalent bond, coordinate bond and metallic bond. Then the weak bond is classified into two types, hydrogen bond and water walls bond. So in the first one is the chemical bond is classified into two types, strong bond and weak bond. So now we see about in strong bond. So in the strong bond is further classified into four types. One is ionic bond and covalent bond, coordinate bond, metallic bond. And now we see about in ionic bond. Okay, ionic bond. So the types of chemical bond. So all the elements have different valence shell. So the valence shell means the last outermost shell in the presence of electron. So beryllium valence electron is 2 and carbon valence electron is 4 and nitrogen valence electron is 5, oxygen valence electron is 6. So all the elements have different valence shell in the electronic configuration. So the way in which they combine to form compound also different. So there are the different chemical bond. So in the different chemical bond is the ionic bond and covalent bond. So it is depends upon the type of bond and their characteristics or properties. So first one, ionic bond or electrovalent bond. So ions. So the ions means in the presence of charges. Okay, ions means in the presence of charges, positive and negative charges. So in the ionic bond is a chemical bond is formed by electrostatic attraction between the positive and negative ions. So in the atom, losses of electron will form a cation is positive ion. So the losses of electron will form a cation positive ion and then gain of electron will form anion negative ion. So the ions in the positive and negative ions come closer to each other due to electrostatic force of attraction and thus the form of ionic bond. So this is called the ionic bond. Then the attractive force of being electrostatic force is called the electrostatic bond. Then the valence concept, the electronic configuration valence concept has been explained in the term of electron is called the electrovalent bond. So in the formation of ionic bond, so let us consider the two atom A and B. So one atom is A and then another atom is B. So in the one atom, so in the A atom is lesser than the stable octet electronic configuration. So the transfer of one atom to B atom, okay, A atom is transferred to the B atom is one electron. So in the A atom will become the positive ion cation, and atom B will become a charged ion to negative ion is anion. So in the positively charged ion are held together by electrostatic force of attraction is called ionic bond or electrovalent bond. So this is the formation of ionic bond. So one example is sodium chloride. One example is sodium and chloride. So the formation of ionic bond in sodium chloride. So this is the structure of formation of ionic bond sodium and chloride. In the sodium sodium atomic number 11 and electronic configuration 281, and one electron is access to the nearest stable electronic noble gases of neon. So the sodium has a tendency to lose one electron, to the losses of one electron in the outermost shell. Okay, so sodium is the last outermost valence electron is 1. So the one electron is losses. One electron is losses. So the sodium has nearest to the noble gases group of neon. Neon atomic number 10. So the last electron is 8. In the presence of 8 is obey the octet rule. Then chlorine atomic number 17, the electronic configuration is 287. So the chlorine has one electron less than to the nearest stable electronic configuration noble gases of argon. So the chlorine has gain of one electron in sodium. Okay, chlorine gas gain of one electron in sodium. So the chlorine has nearest to the noble gases of electron in argon. So the last outermost valence shell is completed 8 electron. So sodium is loss of electron and chlorine is gain of electron. So sodium get positively charged. So one electron loss means positive charge, one electron gain means negatively charge. So sodium and chlorine form the ionic bond, is positive negative bond. So sodium is outermost layer is 8 electron. So the stable electronic configuration, and chlorine the third layer, the third valence shell is completely filled, the 8 electron. So it is the obey the octet rule and 8 rule electronic configuration. So in the next one is the same method. The ionic bond formation method is magnesium chloride. So magnesium is the electronic atomic number 12 and electronic configuration is 282. Okay, 282, and then chlorine 2Cl2 magnesium Mg, Cl2 means 2 chlorine, 2 means 2 chlorines are present, 2 chlorine. So in the green color mark chlorine, 2 chlorine are present. So magnesium in the last valence electron is 2. So 2 electron, 1 electron is attached to one chlorine, then another one electron is added in another one chlorine atom. So the magnesium atom in the last second valence shell completely filled the 8 electron. At the same thing in the chlorine atom, in the 2 chlorine atom, in the outermost layer of valence electron is completely filled in the 8 electron. Okay, so this is the octet rule electronic configuration and their example of sodium chloride and magnesium chloride. So sodium chloride NaCl, magnesium chloride MgCl2. So in this examples, one atom is gain of electron and another one atom is losses of electron. So we will sharing the electron. Okay, we will sharing the electron. So sharing the electron is converted to the last shell. Last valence shell is completely filled. Okay, so completely filled means stable electronic configuration. So the Coastal-Lewis approaches is based on the electronic configuration. Okay, so today we see about what is chemical bond and what is molecule, and there what is octet rule and Lewis dot structure and types of chemical bond. One type is ionic bond or electrovalent bond. Okay, so your homework. So what is ionic bond and their examples? Okay, what is ionic bond and their example? You write in one example sodium chloride examples only. Okay, sodium chloride examples. Okay, thank you children. So next one, all of you write the electronic configuration of the element in the periodic table, first to 15 element. Okay, in the periodic table, hydrogen, helium, lithium, beryllium is the periodic table arrangements order. First to 15 element, you have write the electronic configuration. Okay, thank you children.